Okay, one last example using the dot product. It says this example says find the measure of the angle ACB, that's an angle ACB, for these 3 points. A is 3 minus 1, B is 2, 0, and C is minus 1, 4. Okay, now I could do this geometrically by, trying to plot each of these, and doing this whole thing. 2, 0, minus 1, 4, okay? But, that would be a lot, this would take a lot more work. So I want you to try to do this using vector methods, okay? Let's try this with just with practicing vector methods, okay? So if I'm going to use vector methods here, let's think about what this would look like, okay? If I randomly draw these points, okay? So A is here, C is here, and B is here, okay? And I'm looking for ACB, right? So I'm looking for this angle right here. I need this angle. So if I can create two vectors that emanate from the same point, that come out from the same point, then I can find the angle between those two by using the dot product. So if I were able to find CA and CB, okay, then I can use the dot product to find this angle. So let's see if we can do that. What would CA be? Okay, so we might have to do a little bit of review here. What is CA and CB? That's really what I'm looking for, right? Okay. Well, what would CA be? CA would be the point A, the coordinates of point A minus the coordinates of point B. So I would have to create, first of all, OA, okay? The vector OA, it would be, which would really be from it's just basically 3 minus 1, and minus the coordinates of C, which are minus 1, 4. Okay, so now I can just go straight across here applying subtraction. So I do 3 minus negative 1, which would be 4, minus 1 minus 4, which would be minus 5, and so that is my vector CA. Okay, what about CB? Same process. I'm going to go take the coordinates of B, subtract the coordinates of C from them. So the B is 2, 0, minus C, which is minus 1, 4. Okay, so I have 2 minus negative 1, so that'd be 2 plus 1, so that'd be 3. 0 minus 4 would be minus 4. Okay, so now I have these two vectors. Now I'm ready to do use the dot product and my special formula to find the angle between these two vectors. Okay, and what I'll do here is, let's see. So what I'll do here is I'm going to use my formula here. Cosine of theta equals my vector A dotted with vector B all over the magnitudes of those vectors. Okay, so if I do this, then my vector A would probably be CA or CB, it doesn't really matter, and B would be the other one. Okay, so let's try that. So this would become really CA dotted with CB all over CA times the magnitude of CA, times the magnitude of CB. Okay, and this would become then, let's see, what would CA be? CA, dotted with CB, is what I need to find, right? So let's do that over, I guess we could just do it on top here. Okay, CA dotted with CB is, I multiply the x components together, so that'd be 12, plus these two multiplied together. So be careful with your signs here, it's easy to get these confused. Okay, 5 times 4 is 20. And then the magnitude of CA is going to be this squared plus this squared, so that'd be 16 plus 25 times the quantity 9 plus 16. Okay, so that would be my scalar value. Okay, and if I simplify this becomes 32 over, and I'll just simplify this whole thing here. I get 5 square root of 41, and then this is all equal to cosine of theta, right? So this is still all equal to cosine of theta, and now I use my calculator. because theta is going to be the inverse cosine of this. Okay? So I'd have to use my calculator here. And this, if I do it on my calculator, I end up getting about 1.79 degrees. Okay? And so this is the angle that is between, this is the angle that's between these two vectors. And so therefore you could say, let's just write that over here, the measure of angle ACB is 1.79 degrees. Okay?